Number 10. A novel process for obtaining magnesium from seawater involves several reactions. Write a balanced chemical equation for each step of the process. Okay, so for letter A, it said that the first step is the decomposition of solid calcium carbonate from seashells to form solid calcium oxide and gaseous carbon dioxide. Okie dokie. So I'm just going to say letter A over here. What is going on? It said that calcium carbonate, which was a solid, was decomposed into or formed calcium oxide and carbon dioxide. So it seems like you had to start off with calcium carbonate, right? Calcium carbonate was the start. And you formed your two products, calcium oxide and carbon dioxide. Now we just have to write the actual chemical formulas. So this is just a review, right? Calcium carbonate. Calcium is Ca, right? On the periodic table, it's in group 2, so it's a +2. And remember, carbonate is a polyatomic. It's an ATE ending, which means that it's a polyatomic. You guys have to memorize that one. Carbonate is CO3 2-. Okay, so flashcard it out if you want to put CO3 2- on one side and then the word carbonate on the other. You guys have to memorize them. You're going to see them coming up over and over and over again. So do the crisscross method here. It's ionic. So the 2 comes down here telling me that I need 2 carbonates, but then the 2 from carbonate tells me that I need calcium, 2 calciums. But remember, with ionic equations, you always want to break it down to the simplest form. Both 2's can be divided by 2, right, to get to 1. So I only need 1 calcium and 1 carbonate. So this would be CaCO3. And they told me that it was a solid, so I'm just going to say solid. And this would yield calcium oxide. Calcium is in group 2, just like we said before, so it's a +2. Oxygen is an O, right? It's in group 16 or 6A. It's a -2. And you do the same idea. The 2 comes down here telling me that I need 2 oxygens. And the 2 from the oxygen tells me that I need 2 calciums. But remember, simplest number, you could both divide these by 2 to get 1. So I only need 1 calcium and 1 oxygen. So this would just be CaO. And they told me that that was a solid. So I'm just going to say solid. And then plus carbon dioxide. This is your covalent way of naming stuff because I see the word di here. Di means 2. So when you start seeing these letters, it's always the call it as you see it. They just said carbon, so literally just a C. But then they told me that I had 2 oxygens, right? Dioxide, so CO2. But we should know that carbon dioxide is CO2. And they told me that it was in a gaseous state, so that's a G. G for gas. Now, I just need to balance. Let's see. I'm just going to quickly look and see if anything looks out of the ordinary. I have 1 calcium here. I have 1 calcium here, so that's balanced. I have 1 carbon. I have 1 carbon. That's balanced. And I have 3 oxygens on the left side, but I have 1 oxygen here plus 2 oxygens here. 1 plus 2 is 3. So actually, this one is all balanced already. So that's the answer to the first step. It would be CaCO3, which is a solid, yields CaO, which is also a solid, plus CO2. And that's a gas. And A is over and done with. Now I just have to erase, just so that we can do B. Okay. Da-da-dee-da-da-da. All right, so B, it says the second step in this process is the formation of solid calcium hydroxide as the only product, remember products are on the right-hand side of the equation, from the reaction of solid calcium oxide with liquid water. Okay, so it looks like I'm reacting calcium oxide and water, and I'm forming calcium hydroxide. That's the only product. So for B, I know that I have to have calcium oxide plus water, and that will yield or produce or form calcium hydroxide as the only product. So here it is in words. Now we just have to get the actual compounds. But we did calcium oxide already, right? Calcium oxide was this guy, CaO. So we're starting off good here. CaO. And they told me again that it was a solid. So I'm just going to say S. Plus water. We know what water is, right? H2O. And they told me that it was in its liquid state, right? Liquid water. So that's an L. And that will yield the only product, which is calcium hydroxide. This one is new, so we have to try to figure it out. Calcium, we know, is group 2. It's a 2+ on the periodic table. Hydroxide is a polyatomic. So here's another one that we got to put on a flashcard, right? Hydroxide is OH minus 1. So if I crisscross them, 2+ comes down here telling me that I need 2 hydroxides. And then the 1 OH comes down and tells me that I have 1 calcium. So I can't break this down anymore. So it would just be Ca, and actually let me do this in blue. Ca, now I have 2 polyatomics. I have to put that in parentheses. So it would be Ca parenthesis OH2. And let's see, they told me that calcium hydroxide was a solid. So here I go, solid. Now I just have to make sure that it's balanced. So let's see. I have 1 calcium. I have 1 calcium. That's balanced. I have 2 hydrogens. Now over here I have an H, but there's 2 of them. So I do have 2 hydrogens. And then for the oxygens, I have 2 again. And on the reactant side, I have 1 oxygen here plus 1 oxygen here. So that's a total of 2. So this one's balanced already. That's the answer to B. It would be CaO, which is a solid, plus H2O liquid will yield CaOH2, and that's a solid. And B is checked. Letter C. Okay, here we go. We're getting somewhere. These are going quick. What do you guys think? Letter C. Now it says solid calcium hydroxide is then added to the seawater, reacting with dissolved magnesium chloride to yield solid magnesium hydroxide and aqueous calcium chloride. Okay. So let's see. Calcium hydroxide is added to the seawater, but it's reacting with only dissolved magnesium chloride. So calcium hydroxide had to be reacting with magnesium chloride to yield. Whenever you see that, that means that it's that yield sign. And they tell us that we're yielding magnesium hydroxide and aqueous calcium chloride. Okay. So here's my formula. We now just need to write it in a chemical formula. We already know what calcium hydroxide was, right? Calcium hydroxide was the CaOH2. So CaOH2. And they still said that it was a solid, so S, plus magnesium chloride. Let's see. Magnesium is in group 2, so that's a +2. Chloride is chlorine, that's a Cl. And chlorine is in group 17A on the periodic table, so that's the -1 trend. Crisscross it out, you have 2 chlorines, you have 1 magnesium. So this would just be MgCl2. They told me that it was dissolved, so that means that it's aqueous. If you are aqueous, you will be dissolving. So that's that part. And then we yield magnesium hydroxide. So let's see, magnesium we know is Mg2+, and we went over hydroxide already. That was OH-1, polyatomic. Crisscross it out. I have 2 OHs, and I have 1 magnesium, right? And remember, since I have multiple polyatomics, right, I have 2 OHs now, I need that parenthesis. So this would just be MgOH2. So let me just write that in here. We have MgOH2, and they told me that that was a solid. So we have solid plus calcium chloride. Calcium, Ca2+. Chlorine, just like we saw before, was a -1. Crisscross it out to get the compound. The 2 tells me that I need 2 chlorines. The 1 tells me that I need 1 calcium. So this would be CaCl2. And they told me that that was aqueous, so AQ. I'm sorry that I'm kind of running over this way a little bit. I know I'm interfering with the subscribe button for some of you guys. If you want to hit it, that's fine with me, right? Here it is, whee! But let's keep going. We now just need to make sure that this is balanced. So remember, just pick out the things that look, odd to you. Let's try to group together. Let's see. I have 1 magnesium. I'm just picking out random elements. I have 1 magnesium. I have 2 chlorines. I have 2 chlorines. I have 1 calcium. I have 1 calcium. And I have 2 OHs, right? 2 hydroxides and 2 hydroxides. So once again, this is all balanced. So that's the answer to the third one. CaOH2S plus MgCl2, which is a solid. I don't know why they should be together. Yields MgOH2 solid plus CaCl2, which is aqueous. Actually, let me just erase this a little bit. Okay. And now we're ready for D. Whew, okay, so I could just erase maybe a little bit up here, and then maybe I can grab it, but I'm basically almost done. All right, guys, we are almost there. So C is all done. Let's move on to D. That one was a big one. So check off C. D says now the solid magnesium hydroxide that we made before is added to hydrochloric acid solution, producing dissolved magnesium chloride, so dissolved magnesium chloride, and liquid water. So for D, what do we got? We have magnesium hydroxide is added, literally addition, to hydrochloric acid, producing or yielding or making, so that's the arrow, dissolved, just a fancy word for saying aqueous, right? Magnesium chloride, and liquid water. Okay, so we did the magnesium hydroxide from before. That was MgOH2. And the magnesium hydroxide, they said, was a solid. So S. Hydrochloric acid. We should kind of memorize this scheme. If you see a hydro in the beginning and then a element, right? Chlor, we kind of know which one that's coming from. But if it ends in an ic, so basically if you have hydroblankic acid, so hydrofluoric acid, hydrobromic acid, hydrochloric acid, hydroiodic acid, always has the notation of H is going to be in the front, and hydrogen is a +1, right? It's in the group 1. And then you're going to use the element that it's telling you. In this case, it's a Cl. And remember, chlorine is a -1. So hydroblankic acid, not all the time, tells you that it's a 1-for-1. Sometimes you will have 2 hydrogens. But you can do the crisscrossing here. That totally works. But if you see here, I have 1-for-1. So I just need 1 hydrogen and 1 chlorine. So HCl. And they told me that it was a solution. Solution means that you dissolved. So that's another way of saying aqueous. Looks like we can disguise, an aqueous in many different terms. So if it's a solution, it's aqueous. If it's dissolved, it's aqueous. If they say aqueous, obviously it's aqueous. So this has to be AQ. Yielding magnesium chloride, which we actually did before, right? Magnesium chloride was up here. That was MgCl2, so we don't have to do it again. You can, just for practice, but we're going to skip that over. And it said it was dissolved, so that's aqueous. And water. Water's H2O. And they said that it was liquid water, so that's an L. And once again, I'm running into that button, so let's just scooch it over a little bit. And now we just have to see if we need to balance. Let's see. I'm going to just spot things out that look a little weird. On this side, I have 2 chlorines. On the product side, I have 2 chlorines, but I only have 1 chlorine on the reactant side. So what number would I have to put in front of here to get to 2 chlorines? Oh, I would have to put a 2. And then let's see. This tells me that I have 2 hydrogens, but I have 2 hydrogens. So that's good. But actually, how many total hydrogens do you have? I have 2 hydrogens here plus 2 hydrogens. So I have actually a total of 4, right? 2 plus 2 is 4 hydrogens. I only have 2 hydrogens here. So what number would I have to put in front times by 2 to get to 4? 2, right? And now the hydrogens are balanced. Looks like I have 1 magnesium and 1 magnesium, so that's good. And let's see, the oxygens, I have 2 oxygens and I have 2 oxygens. So now we're finally balanced. So we know the solution, the answer to D now. Let me just clean this up just so that I have the wording here. We have Mg, OH2, that was a solid, plus 2HCl. Aqueous yields MgCl2 aqueous plus 2H2O, and that's a liquid. Finally, to E. Let's see. E's not going to get us, right? We're almost there, guys. If you guys can do this one, you can do any balancing equation. But we need to balance because we can't do any math with the chem equations without balancing them. Okay, finally E comes along. The magnesium chloride is melted and electrolyzed to yield liquid magnesium metal and diatomic chlorine gas. So it looks like for this one, we start off again with magnesium chloride. And it was melted, okay, cool. It was electrolyzed, cool. It yielded, so that means yield, right? The arrow. Just magnesium metal, so just a single, well, just magnesium, and diatomic chlorine gas. Okay. So now, let's try it out. We know what magnesium chloride is already, right? It's the MgCl2. they say that finally the magnesium chloride, which was coming from the previous one, right? They told me that it was dissolved, so that was aqueous. Yeah, right? That was the only one. So aqueous yields just magnesium metal. So this is literally just saying that, okay, I have magnesium, right? And they told me that it was a liquid. So I have to say L for liquid, plus chlorine, so Cl. But now they tell me that it's a diatomic chlorine. Remember, di means two, and atomic means atoms, right? So I have 2 atoms of chlorine. So I have to say I have Cl2. They tell me that it's a gas, so I just have to put that. And there you go. Let's see, is this balanced? I have 1 magnesium on the left. I have 1 magnesium on the right, so that works. And then I have 2 chlorines and 2 chlorines, so that's balanced. And that is your final answer to all of these. Woo! What do you think? If you can do this, guys, all the balancing equation ones, you guys are going to get it. Just make sure that you know how to make your compounds. Do the crisscross method, okay? So let me know how this was. Click the subscribe button, click the like button if you want, if it helped you out. And I'll see you guys all in the next lesson, okay? I hope you guys have a great day. Keep studying hard. And yeah, see you guys later. Bye-bye.